In this module, in part 2, we're going to be talking about units of measure and various other culinary mathematic principles involved. The objectives for this module are: understand the difference between imperial and metric units of measure in the culinary arts, explain how to convert grams to ounces, define and describe yield and conversion factor, explain how to calculate unit cost, describe and explain the yield percent triangle, explain how to calculate recipe cost and plate cost, and how to set the menu price. Accurate measurements are the most important aspect of food production. Let's look at some of those units of measurement. Weight. Weight refers to the mass or heaviness of a substance. It's expressed in terms such as grams, ounces, pounds, and tons. Spring scales rely on coiled springs which can fatigue over time. Balance scales are great for large measurements, but require counterbalances and are not as accurate. Digital scales are accurate and can be converted from imperial to metric with the touch of a button. They come in large and small sizes. Volume. This refers to the space occupied by a substance. This is expressed in cups, gallons, teaspoons, fluid ounces, bushels, and liters. Measuring cups can be large gallon-sized or larger pitchers, all the way down to a quarter cup sized cups. Measuring spoons typically consist of tablespoon and 1, 1/2, and 1/4 teaspoons. Count. This is commonly used in purchasing to indicate the size of an individual item. Count can refer to each item or the case. When ordering by the count, it's crucial to make sure to specify by the each or by the case. There are two measurement systems. U.S. system, also referred to as imperial, uses pounds and ounces for weight and cups for volume. The metric system, which is the most common system in the world, it's a decimal system in which the grams, liters, and meters are based on units of weight, volume, and length respectively. As you can see from this diagram, one is more complicated than the other. Currently, there are only 3 countries in the world that do not use the metric system, although in many cases, most of them use a mixture of the metric system and the imperial system, including our own country in the United States. Liberia, on the coast of Africa, is originally founded by free Black Americans. So it would stand reason that their constitution is actually very similar to the American Constitution. And because of that, they also emulated our system of measurements. Myanmar, which is also known as Burma, is between India and China. And it was a protectorate of the European Union or British Isles at one point. And because of that, they kind of didn't really like the British, so they kicked out everything British that they had, and that included the metric system. But today they still have quite a bit of the imperial system and some metric systems as well.
Okay, I have a confession to make. I've lived in the United States since 2010, and
Alexa, what's the weather today?
Right now in New York, it's 65 degrees with clear skies and sun. Today's forecast has partly sunny weather, with a high of 77 degrees and a low of 61 degrees.
I still don't understand the use of Fahrenheit. Virtually every country on Earth uses Celsius to measure temperature, but the US still uses Fahrenheit. And for that reason, we at Vox often get comments like these. Okay, we get it. Besides the fact that the majority of the world uses it, the metric system makes conversions a lot easier. The Celsius scale even looks simpler. It has freezing and boiling points at nice, round numbers, 0 and 100, where in Fahrenheit, it's a bit of a mess. And of course, this isn't just an issue of aesthetics or weather updates. America's unwillingness to switch over to the metric system has had serious consequences. In 1999, a $125 million satellite sent to Mars disappeared in the Martian atmosphere.
It's a setback to years of work already done. In the vastness of space, all it takes is one navigation error.
And this colossal mistake was largely due to a conversion error between US and metric measurements. Fahrenheit was really useful in the early 18th century. At the time, no one really had a consistent way to measure temperature. But then a German scientist came up with the Fahrenheit scale when he invented the mercury thermometer in 1714. To make this scale, the most popular theory is that he picked the temperature of an ice-water-salt mixture at the 0 mark. He then put the freezing point of water, which is higher than a salt mixture at 32, and placed the average temperature of the human body at 96. From there, he placed a boiling point of water at 212 degrees. In 1724, Fahrenheit formalized that scale and was inducted into the British Royal Society, where his system was a big hit. As Britain conquered huge parts of the globe in the 18th and 19th centuries, it brought the Fahrenheit system and other imperial measurements such as feet and ounces along with them. And Fahrenheit became a standard system for the British Empire across the globe. In the meantime, the metric system was gaining popularity during the French Revolution. It was put in place to unify the country at the national level. So by the second half of the 20th century, Celsius became popular in many parts of the world, when many English-speaking countries began using the metric system. Even America attempted to switch over. The change would have been good for trade and scientific communications with the rest of the world. So Congress passed a law, the 1975 Metric Conversion Act, which led to the United States Metric Board that would educate people about the system. This created the only metric highway sign in the US, the Interstate 19 connecting Arizona to Mexico, but it didn't go much further than that. The problem was that unlike the UK, Canada, or Australia, the law made the switch voluntary instead of mandatory. And of course, people resisted the change and the metric board couldn't enforce the conversion. So President Reagan ended up disbanding the board in 1982. The next nudge to Metricate came when the metric system became the preferred measure for American trade and commerce in 1988, but nothing really stuck with the general public, even though bizarre measurements like feet and Fahrenheit are not doing them any favors. Students have to train for 2 sets of measurements, making science education even more difficult. And companies spend extra dollars producing 2 sets of products, one for the US and the other for metric. There's also an argument for public health. According to the CDC, about 3,000 to 4,000 kids are brought to the ER due to unintentional medication overdose every year. And conversion errors for dosage are to blame. So it seems like a no-brainer. America needs to switch to the metric system to match the rest of the world. But it is still struggling to make that change. That's because it'll take a lot of time and money, but there's no financial proof that this will all be worth it. So unless that change is proven to be economically better, we're not going to be using Celsius anytime soon.
What's 77 Fahrenheit in Celsius?
77 degrees Fahrenheit is 25 degrees Celsius.
Ah.
To move from imperial to metric and metric to imperial, it's important that you have some kind of keystone piece of information. Let's discuss these for each one. For weight, an essential keystone is 1 ounce equals 28.35 grams, or 1 pound equals 0.45 kilograms. This will allow you to be able to move from imperial measurements to metric and from metric to imperial. For volume, a simple conversion is 1 fluid ounce equals 29.57 milliliters, or 1 cup equals 237 milliliters. You can use this to be able to move from a gallon of water all the way over to a liter of water by moving and manipulating, going from a gallon to a cup to a milliliter, and a milliliter to a liter. Recipe conversions are used when scaling a recipe up or down. For instance, if I have a recipe that serves 10 people and I need to serve 100 people, that would be an example of when I would need a recipe conversion. We have to take into consideration yield first. Yield is the total amount of product made from a specific recipe. Yield also refers to the amount of food item remaining after cleaning and processing, but that's for another time. Conversion factor is the number used to increase or decrease ingredients and recipe yields. Step 1. Divide the desired or new yield by the recipe or old yield to obtain the conversion factor. Now this may sound complicated, but it is the most easy and simplest of all maths. We take our new yield, divide it by our old yield, and that's our conversion factor. Step 2, we multiply each of the ingredient quantities in the recipe by the conversion factor to obtain the new quantity. Old times conversion factor equals new quantity. So you can see it's not a complicated procedure if you remember old divided by new.
So you have the perfect recipe, and now you need to feed an army. Well, we can do that. What we need to do is figure out our conversion factor. This is the equation that we're going to use to convert our recipe. For example, your recipe has 4 servings, and you now want to make 10 servings. And to do that, we need to take our new servings, 10, and divide that by our old servings, 4, which equals 2.5, our conversion factor, which you will need to convert your recipe. And here's an easy recipe. We're going to convert this from 4 servings to 10. So we take each item and we multiply it by our conversion factor of 2.5. And we get a few crazy decimals in there, which we need to change to fractions. To do that, you convert that decimal to a fraction. And don't worry, if you can't do that, just Google it. So here's what our recipe looks like for 10 people. Pretty simple, eh? But wait, what if we wanted to go from a 10 serving recipe to a 3 serving recipe? It's the same math, just a smaller decimal equivalent. All calculates out the same. Easy peasy. Just remember your conversion factor.
Converting portion size is also equally simple, and now while this may look complicated, it is really not. Step 1, determine the total yield of an existing recipe by multiplying the number of portions by the portion size. Step 2, determine the total yield desired by multiplying the new number of portions by the new portion size. Now it's simply old versus new, right? We take our new yield and we divide it by our old yield to get our conversion factor again. And then we multiply each ingredient times that conversion factor. So here you can see an example of cauliflower soup. The recipe yields 1.5 gallons, and these are 48 4-ounce servings. We need to produce 72 6-ounce servings. So we first have to figure out what our old yield was. 48 times 4 is 192 ounces. Then we figure out what our new yield is. 72 times 6 is 432 ounces. Then we take our conversion factor by calculating new divided by old. 432 divided by 192 is 2.25. That is our conversion factor. Then we multiply everything in that recipe times 2.25 to get us our new quantity. Additional conversion problems. The following must be considered when converting a recipe. Equipment used. Sometimes the equipment we need is scalable and sometimes it is not. If the recipe says that we need a mixing bowl, well, sometimes we may need to go into a bigger solution for that. Evaporation rates. When you multiply the amount of liquid, sometimes you have to take into consideration that the recipe may tell you to simmer for 10 minutes for evaporation, but when you increase the liquid amount, you may also increase the amount of time it has to simmer to evaporate. Recipe errors, well, sometimes we just make mistakes, and that does happen from time to time. So you always want to double check your recipe and make sure that it's accurate before you proceed. Time it takes to cook a recipe. Just like evaporation rates, sometimes the time is going to adjust. The longer you have to cook something may depend on how much ingredients you start with, or whether you're going to add ice as part of the liquid to cool it down for the cooling down process, or if you're going to let it naturally cool down. All of these factors have to be taken into consideration. Now let's talk about unit cost. We're talking about the price you pay for one specified unit, such as a pound, a can, a gallon, a bunch, an each. All of these are units of measure in that. As purchased, simply put AP. As purchased means this is the condition or cost of an item as it is purchased or received from the supplier before any trimming, any cleaning, or any processing is done for it. So take, for example, an apple. One apple purchased, the as purchased would be the entire apple, including the peel, the stem, the seeds, and the apple meat itself. We would need to convert that as purchased cost to unit costs or prices. If I take my as purchased cost, let's say for instance I bought 10 apples at $10 for the 10 apples, and I divide it by the number of units, it'll give me my cost per unit. So if I use my example, I have $10 worth of apples divided by 10 apples, that's going to give me $1 per unit, or $1 per apple. Let's talk about yield percent. Many ingredients require cleaning, trimming, or boning. For these products, yield is the usable edible portion, or EP, plus the fat, shells, skin, or sinew that's discarded. Yield percentage is the ratio of the usable ingredient after cleaning and trimming. A lot of ingredients yield a lot of yields. So because of that, we tend to use what is known as the Book of Yields. This can be downloaded, it can be found on the internet, and what it allows you to be able to do is look up really quickly what the yield percentage is of an item. Let's say, for instance, I need to know what the yield percentage of broccoli is. I can look it up in the Book of Yields very quickly by looking inside there and finding broccoli, and it will tell me how much of that broccoli is usable. The usable part is my edible portion, and then my yield percent is the ratio of my edible portion to my overall ingredient. Edible portion is the amount of food item available for consumption or use after trimming or fabrication. It's a smaller, more convenient portion of a larger or bulk unit. As you can see from the example in the pictures below, I have a tenderloin on one side that has the sinew and the fat and the connective material still attached to it, including the chain muscle. And on the other side, I have the cleaned, denuded tenderloin, the chain muscle on the side, all the sinew and fat separated. So now I have my edible portion, which is my usable products, my whole beef tenderloin and my chain muscle that's been cleaned on the side. These are all considered edible portions. The other part are considered in the next little bit. Usable trim is the product that is available after trimming off the edible portion, but it is still usable. So in this example, the chain muscle, even though I may not be able to make a steak out of that chain muscle, I still may be able to use it for making kebabs or making stew meat or something along those lines. So it is a usable trim. Trim loss, or simply just referred to as loss, is the waste product that is no longer usable in any other form, and it is destined for the recyclable or the trash bin or the compost bin. Here's an example of a butcher's yield form. The reason why we complete these is so that we can calculate our yield percent for further usage. If you are using the Book of Yields, you can access a lot of this information within the Book of Yields and compare it to how well you do as a cutter, meat cutter, product cutter of any kind, and see if you are doing what is on par with everybody else. So I start with my primary weight, then I have my raw weight, which if you look at this, 6.75 is my cryovac weight. My raw weight is 6.61. That means when I open the bag, I'm actually losing a little bit of weight. And it's a little bit of the bag, but it's also a little bit of what we call purge, or the moisture or the water that comes off of it. Once I fabricate it, I weigh out my usable product that I'm going to use for my primary usage. That's going to be for my steaks. And I have 3.5 pounds. Then my secondary usage is 1.32 pounds. That's going to be my chain muscle on the side. And then my waist weight is 1.78 pounds, which is going to give me a yield percent of 52%. The way I calculate that will be coming up. So looking back at our yield percent, which is our ratio of usable ingredient after cleaning and trimming, if we take that into consideration, then our EP weight after trimming, which is our weight after we weigh it, after we cut away all the sinew and unusable portions, divided by our AP weight, which is our original weight straight out of the container, out of the box. We put it right on the scale. We multiply that times 100, and that's going to give us our yield percent. So let's look at the example that we had noted earlier. 3.5 pounds of usable primary trim divided by our original weight of 6.75 pounds, multiplied that times 100, which gives us 51.85% or 52%. Let's look at calculating yield percent and quantity to purchase. Anytime that you have three variables, you can use a triangle very similar to this. Our edible portion quantity divided by our as purchased quantity equals our yield percent. Our edible portion quantity divided by our yield percent equals our as portion quantity. And our as portion quantity times yield percent equals our edible portion quantity. This is very helpful, being able to determine how much of a product you need to purchase. For instance, if I know that my yield percent on broccoli is 50%, and I go to my recipe and I see that I need 10 pounds in my recipe, 10 pounds in the recipe would be my edible portion quantity. My yield percent is 50%, so I take edible portion quantity divided by yield percent equals my as portion quantity, or 10 pounds divided by 50% equals 20 pounds. And that's how much broccoli I need to purchase. I can do the exact same thing with this that I did with the preceding triangle. This is measuring cost, but you'll notice that one difference is that the EP and the AP are reversed. The AP is now on top and the EP is on the bottom. This is a key distinction for this particular triangle. Because trimming decreases the usable quantity of an ingredient, the cost of the ingredient must be increased by the amount discarded. AP cost divided by EP cost equals yield percent. This is an example of a yield test. AP cost divided by yield percent equals EP cost. EP cost divided by multiplied times yield percent equals AP cost. So if I know how much something cost me, so that broccoli I purchased earlier cost me $5, and I divide it by my yield percent, 50%, now my EP cost is going to be $10. And that's how much broccoli I'm using in that recipe. Even though I'm discarding some of the material, I still have to take it into consideration. All these costing methods are leading up to one simple thing: how to determine your recipe cost and how to translate that into the cost or the price that you charge your customer. Recipe cost, so we start with determining the cost for a given quantity of each recipe, and then within that costing procedures described earlier. We add the ingredient cost together to obtain the total recipe cost. We have our total recipe cost divided by our number of portions that recipe manufactures or makes, and that's going to be our cost per portion. Once we have our cost per portion, we can start to determine our selling price. The selling price is determined by the plate cost. This is the cost of the food that is served. The overhead cost associated with running a business as well is factored into it in many cases. But a lot of associated costs are factored in other places on the profit and loss statement. The food cost percentage is the amount needed to add to a plate cost price in order to achieve a desired profit.
Understanding how to calculate your food cost percentage is essential for every restaurant owner. If you're in the restaurant or food service business, you understand how important it is to keep your costs under control. Being able to compare and calculate your food and beverage costs month over month can be really helpful in the overall management of your business. So how do we calculate food cost percentage? Well, food and beverage costs are calculated as a percentage of the total volume of sales. First, calculate the amount that you spend on preparing a dish. Take all the ingredients that go into that dish and add up the numbers to find your food cost for that item. Next, divide your food cost by the price of that dish. Let's say, for example, that it cost you $1.50 in ingredients to make a burger and fries, and you charge $5 for that meal. $1.50 over 5 is 0.3. Take that number and multiply it by 100 and we get a food cost percentage of 30%. Once you have the food cost percentage of items on your menu, you'll be better equipped to determine if you need to raise or lower your prices to cover your overhead cost. You'll also be able to appropriately change either the menu price or type of ingredients you use if the prices of the ingredients fluctuate. Don't forget that every restaurant will have different food costs.
So what we come down to is determining our food cost or cost of goods sold. To determine the food cost of an individual menu item, you determine the cost of the plate by adding up all the costs per portion that go on the plate. You've got one portion of macaroni and cheese, one portion of broccoli, and one portion of grilled chicken, one of the dinner rolls, maybe you have a side salad that goes with it. And then also I like to factor in the paper and plastic orders that go with it. Even if they don't get it to go, I still factor that in because every to-go order you have, if you don't factor that in, that's a loss that you're going to take. Then I divide by the menu or selling price. Then I multiply times 100 to get the food cost percent. So again, my plate cost divided by my selling cost or selling price times 100 gives me my food cost percentage. We can also use food cost percentage to determine our sell price. The first thing we do is we determine the total cost of all the components in the finished plate, our plate cost. Then we divide the total plate cost by the desired food cost percentage. Plate cost divided by desired food cost percentage equals our selling price. So let's take a moment to pause on that and talk about that because this is something that as a chef I do quite regularly. I take my cost of the plate. Let's say for instance I have a dessert that cost me $1 to make. And my desired food cost percentage for desserts is 15%. And I say for desserts because I have a desired food cost for desserts, for appetizers, for entrees, for salads. I have a desired food cost for each of those. My appetizers and entrees are different. My desired food cost for my appetizers, my desserts are 15%. This is my personal cost that I like to achieve. And my desired food costs for my entrees are anywhere between 30 and 45%, depending on the product that I'm using. Chicken is relatively inexpensive, so I'm going to go with a 30% to a 35% food cost on that, versus a steak, which is way more expensive, and I'm going to be more at the 45% food cost. So when we look at food costs, what we're really talking about is the amount of money that we're paying in order to produce $1 worth of revenue. So if I get $1, 45 cents of that steak entree is being paid by just simply buying food and putting it on the plate. So if I take this model, it's plate cost and divide it by my desired food cost to give me my sell price. I take my plate cost of $1 for the dessert. I divide it by 0.15 because I can't divide by a percentage. I have to turn it back into a decimal. And that gives me a selling price of $6.66. Well, I'm obviously not going to put 6.66 on my menu. What I can do, though, is put $6.95, $7.95. The selling price that you're going to get from this calculation is a minimum selling price. But keep in mind that price value perception, what people perceive to have a value to them, will diminish if that price is priced too high. So you always want to keep that in mind. You never want to go too high, but you also want to go at or above your selling price calculation. So I know that's a lot of information. This is intended to be an introduction to it, a survey to it. There are whole classes dedicated to things such as this. So let's talk about some of the summaries and the takeaways for today. When to weigh and when to measure are often critical to a recipe success. 1 ounce and 1 fluid ounce are not necessarily the same thing. If I have an ounce of flour and a fluid ounce of flour, they may not equal to the same. We're slowly working toward the metric system by incorporating dual measurements on most of our products. If you go to the grocery store today, you don't buy a gallon of soda, you buy a liter of soda. Converting a recipe is as easy as dividing your new yield by your old yield. New divided by old. Use the book of yields because there's a lot of items will have different yields and it is impossible to keep track of it. I actually have a book of yields that I've maintained for over 20 years. It's got tabulations on them. The material in it doesn't really change. They just add some new stuff every now and then. But you can find all this online, and I highly recommend picking up a copy of it or an electronic copy of it, or at least know where to get that information online. Remember, for the EPQ and the EP dollars triangle, the EP and the AP are reversed. And 6, know your food costs. Be aware the cost will change when the price of the ingredient changes. So when the price of meat spikes up, your food cost is going to spike up, which means you're going to get less of that dollar. Your percentage is going to go up. You're going to get less of that dollar in return.